Hey guys, so this is to run through a practice assignment with you for identifying ratios, and also writing equivalent ratios in a table. So this first problem is just asking you to be able to know all the three different ways to notate or write a ratio. So they start off in fraction form, 7-4, and they ask you to keep the numbers in order because that's how you keep it as the same ratio. But what are the two other ways that you could write that? So if it's fraction form, the other option would be this form right here with colons. They look like snake bites, right? And you want to make sure that you are keeping your numbers in order. So if it's 7-4 in the fraction, it needs to be 7-4 in your colon. And then of course, I'm actually using the words 7-4. So that's going to be my next time around, 7-4. So those are your three different notations: fraction, colon, and writing with the word to as you're comparing them, right? This to this, okay? Checking our answers. Ta-da! Okay, I would hope we would get it right, correct? Okay. So to continue on, here's another one. Writing the ratio 7-9, and they're comparing 7 to 9 in that order. So we need to keep it in the same order even when we write it using different formats. So if this is using words, I know another way to do it is using fraction format, right? So I'm going to do 7 to 9 in the same order. And so now I've used words, I've used fractions, and then the next format is using our snake bites, our colons, okay? Oops, got to click on the next one. Okay, so here we go in the same order, 7 to 9. And I'm noticing as I'm doing this, my cursor kind of goes in places that I'm not expecting it to go. So just as you're filling this out, be careful that you're looking at your screen before you hit submit, because you may know the answer, but the cursor is kind of acting funky, and then you could end up getting it incorrect, even though you actually know your answers. So I am finding that out for you. Let's try another one. This should be a different type. Okay. So Jose is playing a video game, right? And he has collected these items. Okay. So this looks like some kind of potion, and I don't know, like an electricity ball or something, and then magic keys. Okay. So build a diagram to show the ratio of orbs. I guess those are like the little electric balls, right? The ratio of orbs to keys. So I'm comparing how many of these electric orbs there are and keys. So I know for, I also have this nice little table here that kind of gives me the answer. So build a diagram to show the ratio of orbs to keys. I know I have 1, 2, 3, 4, 5 orbs. And if I couldn't count them, they're actually there in the table for me. So I'm going to put, I'm just kind of laying it out. 1, 2, 3, 4, 5 orbs. Orbs, 5 orbs. Whee! To how many keys? 2 keys, right? So there's 2 keys. So notice this little swirly mark down here is just focusing on the blue, right? Those are my orbs, 1, 2, 3, 4, 5. And this little swirly gig right here is just pointing on the green. So that's 1, 2 keys. Okay, so that's why I'm going to label that one keys. Well, if I've already labeled orbs and I've already labeled keys, what do you think this swirly gig up here is going to represent? Without even giving you any options, what do you think it represents? Well, if I go back, it says Jose is playing a video game and he has collected these items. So I'm assuming without even clicking on it, it's going to be like total items, right? Or things that Jose has collected. So yeah, the title, they do give all items. But now that I see the other options, I realize that if I click all items, that would mean that it includes the potion, the keys, and the orbs, and it doesn't. I don't have all 3 represented, so I'm not going to collect or click all items. Instead, I am going to click on the orbs and the keys because that's the only thing that I have represented. Ta-da! Okay. Oops, fill in all the empty boxes. What did I forget? What did I forget? I honestly, You can scroll down. Have you ever done that before? That's kind of odd. Okay, sorry. Right, I'm just telling you all the ways you can mess up today. Okay, so write the ratio of orbs to keys. So again, this is just writing in a different notation. How many orbs did we have? We have 5 orbs and we have 2 keys. And normally I would say make sure that you simplify it, but those cannot be simplified any further. So now we are ready to move on. Here we go. Okay, so just checking. I'm trying to move my cursor. There's nothing hidden down below. Okay, so there are 5 red marbles and 6 blue marbles. So automatically in my brain, I am trained to know 5 red marbles, 6 blue marbles. So I'm trying to assume how many marbles are there total in the bag. There are going to be 11 total marbles. I don't even know if they're going to ask me anything about that yet, but my brain is also being trained to recognize that there's a total. Every time I compare parts, it also is going to equal a total. Okay, so what's the ratio of all marbles in the bag to blue marbles? Well, like I said, all marbles is going to be, I'm going to click on this so it gives me like my format. All marbles, there's total of 11. And then blue marbles is 6. So my ratio would be 11 to 6. And then what's the ratio of blue to red? Well, blue is 6. Ta-da! Blue is 6, and then the red was 5. And again, I think they're switching up the order just to make sure that you're reading for detail. So this is almost like an ELA example question as well. Make sure you slow down and you know what order they're asking you to put your numbers in, because the rest of it's not really that tricky. I think I messed up and there we go. I had an extra. See, I just keep making these little errors. Okay, I need to slow down. Okay, here we go. Another one. In a produce display, there are 6 avocados for every 5 peaches. Hopefully, you know, like the produce department in the grocery store. That's where we're going to find like your veggies and your fruits. Okay. So write the ratio of avocados to peaches. And in the actual example, avocados and peaches, it's in that order. So I can keep the order as 6 to 5, right? Can it be simplified? No. If there are 42 avocados in the produce display, how many peaches are there? Okay, so this is taking some time. I want to kind of draw this out. So this is where I get to actually use my handy dandy new little app here. So we said there are avocados and there are peaches, right? And then there's going to be a T for total, I'm going to say, okay? I'm going to kind of draw my little lines. I apologize. I have to draw with my like fingers on my computer trackpad. So it is definitely not as cute of handwriting as what I'm used to trying to do for you guys. Okay. So we have, if in this example, we have 6 avocados. That's horrible. Can I like undo that or okay. I don't even know what happened there. Okay, so if I had 6 avocados, wee, and I have 5 peaches, wee, then I know I have 11 total pieces of produce, right? All together. So now they're saying, whoa. So instead of having 42, or I'm sorry, instead of having 11 total avocados or 11 total produce or 11 total peaches, we are going to look at this and it says 42 avocados, right? So where I have avocados listed, I have a 6 so far. I'm going to go through and I'm going to choose 42 right here, right, with my lovely handwriting. And then your whole goal is, if you can remember, we're trying to keep everything proportionate, right? Which is the same thing as when we talked about equivalent fractions. We're keeping it equivalent or proportionate in our ratios. So all you're really doing is asking yourself that math problem, right? So 6 times what gets me 42? Well, I know if I take 6 times 7, sorry, it takes me a minute to write this, 7. Then whatever I do to the 6 to get to 42, I have to be proportionate or equal. So now I know I'm going to take 5 times 7, right? So what is 5 times 7? 5, 10, 15, 20, 25, 30, 35, right? So I'm going to do 35 here. Whee! Do you know how many pieces of produce that would be total? If I took avocados multiplied by 7 and peaches multiplied by 7, that means my total amount is actually greater by 7 times more total pieces of produce. So I'm going to also do that just to kind of give you guys in the habit of doing it. It's not really necessary for this problem, but it's nice to keep it in mind so when you are asked to do it, you're not completely thrown off. So in general, if we have 42 avocados, we are now going to also have 35 peaches for a total of 77 pieces of produce because everything is now 7 times the original amount. Okay, so how many peaches are there? Long story short, we are going to do, click 42 avocados. So we're going to click 35 peaches up here. Okay. Checking. Checking. Okay, here we go. Oopsies. Let me just clear that off for us. Sorry. Still getting used to this, so you know. Cool. Okay. So using this scenario, right? It looks really difficult because there's a lot of words, but other than that, it's really not. Okay, so they're going to give you a ratio, and then you kind of have to see if that's really what they're saying or not down below. So the ratio of apples to oranges is 8 to 7. So just to kind of help you guys out, anytime you're doing this, I would recommend, honestly, I would recommend going through and just drawing pictures. It always helps me anyway. So if I have apples, 8 to oranges. Oh, okay. So I have 8 apples and I have 7 oranges, correct? Okay. So now that I kind of have that to visualize picture-wise from the original that they gave me, it's asking me to, hey, read all of these statements down below and then check it off if it's also true. So this says there are 7 apples to every 8 oranges. 7 apples to 8 oranges? No, that's not at all what they said, actually, right? That's actually the opposite of what they said. So I'm not going to click that, right? So the next one says for every 8 apples, there are 7 oranges. 8 apples to 7 oranges. Is that what they tell us? Yeah, that's exactly what they're telling us, right? So, I don't know if it's actually like telling you what I'm showing you or not. So I'm hoping that it does. Oh, that's kind of nice, right? So yeah. So if it says for every 8 apples, there are 7 oranges, 8 apples, 7 oranges. Yes, that is it. So I'm wondering if it'll let me, yay, still lets me click. Okay. So for every 8 oranges, there are 7 apples. 8, does that represent oranges? No. So I'm not going to click that. The next one says there are 8 apples to every 7 oranges. 8 apples to every 7 oranges. That's exactly what they say. So I'm going to click that one. Cool. And then you only click none of the above if none of them were true. Okay. So I'm going to check it. Notice all they did was kind of tweak the wording just a little bit, but they're just trying to get you used to it. Okay. Here we go. Next one. And I need to go through and figure out how to clear your screen. There we go. Okay. So, here we go. A printer is printing photos. For every 10 photos, the printer takes 2 minutes. Sadly, that printer is a lot faster than the one we have here at school. Okay. So for every 10 photos, the printer takes 2 minutes. Okay. And again, like I said, I go through and I just like to write it out. So I'm going to draw it out. Okay. So there are 10 photos. Here's my P for photos. Well, actually, I'll just write it out because They both start with P's, don't they? So here's photos, right? There are going to be 10 photos. Actually, you know what? Let me just do this. I'm going to do, for photos, there's going to be 10 of them, right? 10 photos. And then the printer takes 2 minutes. So I'm going to put the M for minutes, right? Okay, cool. So now I'm going to go through and say, let's go through and try to figure out how we can kind of finish out this ratio table, right? Everything needs to be equivalent. So I have 10 photos for 2 minutes, and I want to stick with that, right? So this is kind of the funky part, because normally I said in our videos, like, you want to stay proportionate. So you're looking for some kind of multiplication problem, right? But if I think of 2, can I multiply 2 by something to get to 5? Not evenly, right? So that one's going to be kind of tricky. So I'm going to think about that one for a second. Okay. Instead, I am going to go back and I'm going to do the ones that are kind of more obvious to me, right? So if I think about this, I know if I have 2 times 4, right? If I multiply by 4, I'm going to get 8. So that means I'm going to go through, and for this guy right here, I am going to click on it, and I know I have 2 times 4 here, so I'm going to do 10 times 4 to make it 40. Okay, are you with me so far on that one? We did times 4 for both of them. Okay, we're being equal to both of them, equivalent, right? So how would I get, I'm going to use a different color just so it sticks out. 10 times what will get me 50? 10 times 5. Okay, so that means whatever I do to that, I'm going to do here times 5. So 2 times 5, that means I'm going to go through and click in 10 here, right? 2 times 5 will get me 10. Okay, so now let's go through, now that we have those figured out, is there anything else that kind of stands out in our head now? What patterns could be used to figure these out? Okay, you don't necessarily have to stick to this 10 and 2 in order to fill out this next column here. Okay, so what sticks out in my head automatically is I have a 5 right here and I have a 10. Okay, I'm just looking for connections that I can easily make using multiplication. And in my head, I know how to get from 5 to 10 easily using multiplication. So I'm going to say 5 times 2, right? So if I'm taking 5 times 2 to get 10, that means I have to do the same thing here. What times 2 is going to get me 50? What times 2 gets you 50? If you know your quarters very well, that one should be kind of easy, but I know we're kind of struggling with the quarter thing right now. So it's actually 25 times 2 will get us 50. So 25 times 2 and then 5 times 2. Cool. So now let's look at any of our other ones. Can we find a pattern to figure out this guy right here? Right? Is there anything in here that we can use to get 35 or possibly from one of these to another? Are there any hints? Okay, so what I want to point out with you guys is I'm still going to use this whole concept of 10 and 2, right? For every 10 photos, it takes 2 minutes, right? Well, in order to figure out this funky one that's kind of in increments of 5, right? I'm like, I can go through and I can think, I could probably break this down even easier. If it takes 2 minutes for 10 photos, how many photos are going to be created in 1 minute? So essentially all they did was take half of 2, right? So it's half of 10. 5, right? I can create or print 5 photos every minute because I know in 2 minutes I can create 10 or print 10. Okay. So we call this a unit rate. And that's actually leading us into our very next lesson, which is perfect. Unit rates are your best friends. Unit rates break it down to the easiest vision possible so you can do all future math in the problem. Okay. If I know how many photos I can print in 1 minute, I can answer everything from here on out, right? Because think about it. Now it's really easy for me. I'm going to change colors just so it sticks out. Now it's really easy for me to get to 35, right? Because I know 5 times what is 35. If I do 5 times 7 is 35, then I know I can take 1 times 7 to get 7, right? So that lets me know, using a unit rate, busting it down to 1, that lets me know that in 7 minutes, I will be able to print 35 pictures. Okay. So I'm going to put my 7 minutes right here. And now we can move on, right? Okay. So here we go. We are going to, okay. So to finish off here, we have one more problem. It's Felipe, and Felipe is selling raffle tickets. For every 4 tickets, he charges $32. So to kind of tag on to what I was just talking to you about with unit rates, I'm going to jump in right there, just so it's fresh in your mind, okay? So we're going to start off with this specific scenario, this ratio right here, and we're going to say, okay, for 4 tickets, right, it's $32. Yeah. So let's bust it down to the unit rate, which means 1. Okay. So if it's $32 for 4 tickets, how much does it cost per 1 ticket? That's our unit rate when you break it down to 1. So this is what we want to try to figure out here, right? That will be our, I'm going to try to write it, unit rate. Okay, breaking it down to 1. It's your best friend in math problems. So how do you get from 1 to 4 using multiplication? Hopefully that sticks out really quickly and you know that all you're doing is multiplying by 4, right? So what times 4 gets you 32? 8, correct? So that lets you know 1 ticket costs $8. Now you can figure out everything from here on out using this unit rate. Okay, so give me 1 second. Okay, so we just figured out that 1 ticket is $8. So let's use that knowledge to help us figure out the rest of this table up here. Okay, so if 1 ticket is $8, how much is it going to cost for 5 tickets? Well, I can actually go through and just use this scenario, this ratio, and I'm going to say instead of 1 ticket, I have 5, right? So you're just using equivalent rates every time. So 1 times 5 gets you 5. So that means you have to do the same thing to the cost. Take that cost and multiply it by 5, right? So 5 tickets is going to cost you $40. So let's keep going. Okay, so now we're asking us, okay, so how much would 7 tickets cost? Well, if 1 ticket costs $8, how much would 7 tickets cost? And again, all I'm doing is using the unit rate to help me figure it out. 1 times 7 gets me 7. So to be equal, I have to do the same thing to the cost, right? So I'm going to take that cost of $8 and multiply it by 7, which gives me a cost of $56. Cool. And just to stick in the same pattern that we're in right now, I'm going to skip over this middle one because it's kind of asking you to find the opposite. It's asking you to find the number of tickets. So I'm going to stick in the same pattern and go to this one, right? Because we've already done problems where we knew the number of tickets. So let's keep going with knowing the number of tickets. So in this specific problem, instead of having one ticket, we have 10 tickets, right? And we want to know how much it costs. So same pattern. 1 times 10 gets us 10, right? So if I take the number of tickets times 10, I have to take the cost and multiply that by 10, right? So that would give me $80 for 10 tickets, okay? So on this last one, we're given a little bit of different information. Instead of knowing the number of tickets, we know the cost. So we're going to start off with the cost instead. So I'm going to set it up to be equivalent, right? My cost is $72, right? So that's what this is, $72. And I want to know how many tickets that will get me. Okay, it's the same scenario or the same setup. I'm still finding an equivalent way to do it. So 8 times what gets me 72? I know that 8 times 9, right, gets me 72. So I have to do the same thing to the top. The number of tickets is going to be multiplied by 9 as well, right? So I know that if I give them $72, they're going to give me 9 tickets. Okay, for our last problem, I'm going to go through and clear out my screen real quick. Okay. So for this last problem, it is saying Rachel is driving her motorhome. I think most people call them RVs, but we're going to say that. So she's driving her RV and it uses 4 gallons of gas for every 28 miles she travels, which is not great gas mileage, guys. So she is able to drive for 28 miles. And it takes her 4 gallons of gas to do that. So we want to complete the table below to show how many gallons she's using based off of how much she travels. Okay, so it's the same concept. I'm actually going to pause the video and have you solve these out, see how well you do, and then check back with me for the answer. Okay. So to start you guys off, I hope you went through and said, okay, I'm going to find my unit rate to make things easier. If I can put 4 gallons of gas in my RV and go for 28 miles, then I know I can break it down to my unit rate. And I can say, how far can I go on 1 gallon of gas? Well, if it takes me multiplying by 4 to get from 1 gallon of gas to 4, then I know I have to do the same thing here, right? So I'm going to take 7 times 4, and that would give me 28. So that's how I found my unit rate. I know for every 1 gallon of gas, I can go 7 miles. And from there, I'm just going to fill in everything else, right? So, nope. Okay, so for every 1 gallon, I drive 7 miles, right? So if I'm taking 1 times 7, I'm going to take 7 times 7, and I'm going to get 49. Okay. Then I ask myself 1 times what gets me 10? 10, right? So that means I need to take 7 times 10, and I'm going to get 70. Correct? Well, using this unit rate all over again, right? I'm asking myself what 7 times what will get me 63. Okay, so 7 times 9 will get me 63. So I need to do the same thing to the top. 1 times 9, and that gets me 9. Ta-da! I hope this helped